This is question 5 from the SACE Stage 2 Physics course companion from Subtopics 2.3 and 2.4. Here we have a proton moving in a magnetic field of magnitude 645 microtesla at a speed of 2.3 times 10 to the power of 5 meters per second. First, we need to work out the magnitude of the force acting on the proton. That's fairly straightforward. We have the relationship F equals QVB. We know all the information here. The charge of a proton has the same magnitude as the charge of an electron, which we know is 1.6 times 10 to the power of minus 19. Speed's given in the question. That's just 2.3 times 10 to the power of 5 meters per second. And the magnetic field strength is 645 micro, so 10 to the power of minus 6 Tesla. Substituting that into our calculator, we get 2.37 times 10 to the power of minus 17 newtons. That's fairly straightforward. Next, we have to calculate the acceleration of the proton, and the proton has a mass of 1.67 times 10 to the power of minus 27 kilograms. Here it is using Newton's second law, so A equals F on M. We've just calculated the force. So it's 2.37 times 10 to the power of minus 17. We're told the mass, 1.67 times 10 to the power of minus 27. Substituting that to the calculator, we get 1.42 times 10 to the power of 10 meters per second squared. So that's fairly easy. Part C, we're working out the radius of the circular path using our previous value, because it says hence determine the radius of the circular path. So since it's moving in a circle, it's undergoing centripetal acceleration. That acceleration is just given by v squared on r. We can just rearrange this easily enough to be v squared on a, and now just substitute the values that we have. So 2.3 times 10 to the power of 5 all squared divided by the acceleration that we just calculated. And if we substitute that in, we should get 3.72 meters. That's not so bad either. Finally, part D. Suppose we have an alpha particle with a mass of 6.64 times 10 to the power of minus 27 kilograms. Entering the same magnetic field at the same speed. How does the circular path differ? So here, just write down all the things we know from the question. That since it's an alpha particle, the charge is double, so our charge goes to double the charge. And we're told that the mass is 6.64 times 10 to the power of minus 27 kilograms, which is about 4 times the mass of a proton. So we have our mass is going to approximately 4 times the mass. Now we know from our expression R equals mv on qb that the radius is proportional to m on q. They're the two values that we have. Here we have the mass is increasing by a factor of 4. Charge is increasing by a factor of 2. So using both of these values, we can see that the radius will increase by a factor of 2. So here the radius of the circular path will double if the proton's replaced with an alpha particle. This is a little bit tricky because you have to look at both things which are changing. So it's not just a simple, straightforward proportionality question where only one thing changes. You have to consider both simultaneously, and you may get a different answer, depending on the situation. But here, it's fairly straightforward. Yeah, charge is doubling, mass is up by a factor of 4, so the radius of the circular path will double. That wasn't too bad. Nothing too exciting there, but yeah, fairly straightforward and covers all of the circular motion concepts that are really needed for this part of the course. And that's it.